best dog ever last part. Hola everyone, so final step of our journey, the painting printing of the medal. You have already seen the results in the introduction, so no surprise, it is working. Usually if your STL file and your slides file are done correctly, you have nothing to do, it's just a press button process. So I will try to give you a few details about the printing, and first of all I'm using an elegoo Saturn II printer. When you open the box you can see that there is a plate just above a reservoir of liquid resin. If you remove the resin you will uncover a LCD screen of 25.4 cm. The resolution of the screen is around 7000, so if you divide the resolution by the screen length you can calculate the pixel size of 33 micrometers. It is really good and needed if you want to print a 2D picture like our goal. The price of such a printer is reasonable and fixed around 400 euros. LCD means a liquid crystal display. It is an electrically modulated screen for which the crystal orientations change if you apply a potential and will let the light pass or not. This is an empty reservoir with a bottom transparent. When it's full of resin you can start the printing of your Chitubox folder. The plate goes down and each slice will start to solidify one by one. After a few hours you can remove the metal that stick to the moving plates, be careful to the resin and clean it before it solidifies. You can use a bath of methanol to remove the resin that is still liquid, but be careful with the methanol. I think that there is a less toxic solution in the market. Some resins are water washable, for example. Then you can separate the support from the metal, and after that you can irradiate the metal 20 minutes with UV. You do that to totally polymerize the plastic. The support are letting some dots on the surface, so you can sand down the metal to make it flat. I will try also to print it with a printer filament, but here I'm not expecting a good result because the resolution is lower. This printer has lower resolution, so if you want to print the metal, it is better to print it vertically with some supports. It is also more expensive, but I use it to print larger volumes faster. Okay, and the last step, the painting. The first idea I got was the electrodeposition of copper on the surface. For that you need to flow a current between two electrodes. The anode is composed of pure copper. There is an oxidation of the copper at the anode and the copper ions are created and will then be reduced at the cathode. We need to apply a potential to drive the redox reaction in the non-spontaneous direction. A bioelectrolytic solution is also needed for the ions be able to travel. This idea seems elegant, but the tricky part is to use the cathode as plastic because it's not conductive at all, so the electrons cannot flow. One solution is to use a composite PLA that is slightly conductive thanks to carbon fibers mixed with the PLA. Here you can see some deposition of metallic copper on conductive PLA I printed. You can see that the copper was deposited only on some specific part, and I suspect the conductivity to be highly inhomogeneous. Here below you have the link of a paper comparing different commercially available conductive filament. It is really challenging because the PLA is 3750 less conductive than normal copper. Another solution is to use a colloidal paint based on copper that you can apply on your plastic to make it conductive before the electrodeposition. It works because I was able to cover an electrode in plastic and I tried it in an ion mass spectrometer, so it was able to emit electrical field. But this is another story. For our dog we don't care about conductivity, so let's use color bombs.
Et ces gros doigts là.
J'ai fait tout doré. Oh, regarde les ongles.
Qui me fait penser au bonhomme là qui reste immobile.
Ouais. Ça couvre pas mal, hein. Elle est belle la couleur en vrai.
Best dog ever.
Ouais, c'est pas mal.
We arrive to an end. Don't forget the two first parts. Enjoy creating and subscribe.